In this problem, we have a matrix. For the record, HackerRank is not my favorite platform, but here we are. It is also at this point, it probably will be eventually, but it's currently not tracked on CodeTrack. But we were talking about matrices, and I had just worked through this problem with some students, so it was on my mind, which is why it came up. I think the problems are great. I just don't like the way they structure their data. So we're given a 6x6 matrix, and the matrix is a series of arrays. So we think if we have one big array, and inside that big array, we have 6 arrays, and each of those 6 arrays has 6 numbers in it. They might be zeros or ones, but they also might be positive and negative numbers. We can see a variety of things here. What we want to do is we want to look at a box of 3 by 3. So sort of like these 9 elements. We want to find the sum, but we want to exclude this one and this one. So we can see that shape represented there by the ones. So the sum of this hourglass, as they call it, is 3 across the top, then 1 in the middle, and then 3 across the bottom, which is 7. So our current total is 7. Then we shift over 1, and now we're looking at these 3. So 2 plus this 1, 0, plus these 3, which is 4. And 4 is not greater than 7, so 7 is still our max value. Then we look at this one, which is 3 numbers crossed out at a total of 1 plus 0 plus 1. And then we come over to these, and this is, of course, all zeros plus 0 plus 0. So we've seen a 7, what was it, a 4, and a 1, and a 0. 4 possibilities. Then we go to the next row, and we do it again. So here we see 1 plus 3 is 4, plus all zeros. I'm sorry, that's not, it's just the 1 there. So it's 1 plus 1 is 2, 3 zeros, 2, and so on and so forth. That's how we go through this problem. We have a few minutes. I'm just going to go through this one rather quickly, given our time here. The way I would look at this problem is I would say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let me just copy that. Great. I would say, okay, where are all of the top left corners of the hourglasses I need to visit? So there's one here, right? Because I need to go 1, 2, 3, and then down 1, and then get these 3. And there's one here. Let me just do those lowercase. And one here, and one here. But there's not one here. If I start an hourglass here, I'm going to run off the page, right? I got 1, 2, oh, too much. So that's not one. Now these are, and these are, and these are. But once I get to here, also I've got a problem. I can go over 3, but I can't go down 3. So there's no top corners here, and there's no top corners here. So the first thing I want to do is write a loop that visits all of these ones that are x's. Let me try and demonstrate that real quick. So I'm going to write a nested loop. I'm going to say for let I equals 0. I is less than, now I is going to be going down. So I've got 0, 1, 2, 3. I is less than 3, I plus plus. And then inside of that, I'm going to set j. J is going across here. So j is less than 0, 1, 2, 3. I'm sorry, less than 4. And this is also a mistake. It needs to be less than 4. J is equal to 0. J is less
that
than...
That would be length minus 2, right?
Say that again?
Yeah, that would be length minus 2, right?
Could be length minus 2, yes. Because we know that it's always going to be 6 by 6, I would tend to just put an actual number here. But if we didn't know for sure what the length and height was going to be, then I would do minus 2. Make sense?
Yeah.
Yep, okay. Then I'm going to print out array at I and j. And let's start running that and see what we get. Okay, so here's my input, right? So I expect to have a 1, 1, 1, 0, 0, 1, 0, 1, etc. All those ones printed out. And I see 1, 1, 1, 0, 0, 0, 1, again, 1, 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0. That's here, 1, 1, 1, 0. In other words, I printed out the first 4 numbers of the first 4 rows. That helps me find all the top right corners. Then you're welcome, Akira. Thanks for the nice note. Okay, now here I'm ready to find my current sum. My current sum is going to be array at I and j plus array at I and j plus 1. And my array at this plus 2. Given that this is going to be kind of long, let's do something like this. Let's say let top row equals this. Let middle element. What is that? That's array at I plus 1. That takes us down a row. And j plus 1. That takes us over a row. And now I've got let my bottom row equals exactly this, but I plus 2. You follow me there?
Yes.
Okay. Then my current sum is just going to be top row plus middle element plus bottom row. So far, so good?
Yes.
Okay, I'm going to delete this now that I've used this as a demonstration. We'll say let our max equals, here we want to do negative infinity because our max value could end up being in a negative value. So we want to start at negative infinity. If current sum is greater than max, max equals current sum. And finally, return current sum. And what do you know? We're done. I got a typo, top row plus middle element plus bottom row. Yep, I got an extra character there. Return current sum, my bad. That needs to be return max. Okay, and so this is the 3 test cases they give us. And given our time, I'm just going to go ahead and submit that. Of course, I would typically test it more thoroughly. And that passes all of the cases. Does that solution make sense to you?
Yes.
Okay. So my biggest trick here is just thinking to myself, where in this array are my reference points? If I'm looking at every row, then my reference point is the first character. If I'm looking at every 3 characters, then my reference point is every time I find, a start of that place. Here, my easiest reference point for me is the top left corner of that hourglass. We could just as well use the top right or the middle. I just think it makes the most sense to use the top left. Given the top left, how do I then build out the hourglass? I do that right here. Great. How do I add them all together? I do that right here. Nothing left to do but compare it to our running max and then return our max.
Yeah.
Sound good?
Yes.
Okay.